Hello, Algebra 2 students. Today we will do 1.1 and 1.2 notes. In these notes, we will talk about the real number system and we'll talk about how to evaluate and simplify algebraic expressions. Let's get started with some vocabulary. Real numbers are all the numbers. These include positive, negative numbers, fractions, and decimals. Examples: 5, negative 13, 1/8, 0.75. So I'm going to sketch a picture of the real number system. So you have real numbers. And then within the real number system, you have like subsets basically. So you have what are called the rational numbers or the irrational numbers. So I'm going to draw a big rectangle within here. And then here we have irrational numbers. So the real numbers can be rational or irrational. So here's rational. Rational numbers can be written as fractions or decimals that end or repeat. Examples of rational numbers are 7/8 because that is a fraction, 0.33 where the 3 is repeating. Another example would be the square root of 16/9 because that simplifies to the square root of 16 over the square root of 9, which is 4/3. So we have the rational numbers. Then we have what are known as integers or whole numbers. So I'll go ahead and sketch this little portion. So within the rational numbers, you have integers, you have whole numbers. And let's talk about the whole numbers first. So the whole numbers, we'll skip irrational for a second, are 0 and all positive numbers. We start with 0 and think about it, the letter O here. So it kind of tells you start with 0. There's also a type of numbers that I haven't put on here, and those are called natural numbers or counting numbers. And that's what you learned with when you first learned how to count numbers. So if someone told you to count to 10, you never said 0, 1, 2, 3, 4 when you're 2 or 3 years old. You'd always say 1, 2, 3, 4, 5, 6, 7. Those are natural numbers. Whole numbers just include 0. So examples: 0, 1, 2, 3, 4, and so on. And then we have integers from that whole number. So the whole numbers are the integers are negative and positive numbers. But no fractions or decimals. You can have a fraction like 6/1 because that simplifies to 6, which would be an integer, but you can't have something like 6/7. That would not be an integer. And examples include -4, -3, -2, -1, 0, 1, 2, 3, and so on. Okay, and then lastly, we have our irrational numbers. Irrational numbers are not rational. So basically, these are your decimals that don't end or repeat. They can't be written as fractions. So an example would be pi, because pi does not repeat. It just has an infinite number of digits, just no repeating pattern. Another example would be square root of 11. And yet another one would be 0.303003000. Notice there's no repeats. Those none of the digits repeat in a repeating fashion. Dot dot dot. All right. So that is the real number system. Now that you know about some of the real numbers, we are going to do examples. First one, graph the real numbers square root of 5 and 7 halves on a number line. So we know that 7 halves is just 3.5. Square root of 5 is between square root of 4 and square root of, well, it's close to square root of 4. We don't even need to get to square root of 9. And we know square root of 4 is 2. So the square root of 5 is going to be 2 point something. We don't really care, just that we know it's going to be smaller than 3.5. So if we were to graph it on a number line, both numbers are positive, so you could just put 0 on your number line. 1, 2, 3, 4. And so here is 7 halves. And there would be, somewhere over here would be square root of 5. And there you go. That's how you graph the numbers on a number line. Okay, example 2. You work 8 hours and earn $60. What is your earning rate? So for this particular problem, to find out your earning rate, you're going to take the money that you earn and you divide it by the number of hours that you work. So in this case, that would be $60 divided by 8 hours. Notice how I have my units listed, dollars in the numerator, hours in the denominator. Now you can divide top and bottom by 4. And that would be 15 over 2, which is easily recognizable as 7.5. So that would be $7.50 per hour. You could also write it like this. And always make sure you put your units. So that bar means per or divided by. Okay, example B. You buy 18 gallons of gasoline at $2.65 per gallon. What is your total cost? So your total cost would be equal to the number of gallons times the cost. So you would take 18, which is the number of gallons, times 2.65. And that would give you $47.70. I would just use a calculator, no sense in taking time to multiply it out. Right, and example C, you drive 90 kilometers per hour. What is your speed in meters per second? So this one will take a long time, and this one we're going to use what is called unit analysis. If you take chemistry or have already taken it or are currently taking it, you are going to do a lot of unit analysis, and I'll show you how I go about doing it. So notice it's 90 kilometers per hour. Per means that fraction bar. So we are going to write 90 kilometers per hour, just like that. And our goal is to get our answer in meters. So meters should be in the numerator. That per tells you that the second will be in the denominator. So this will be in the denominator, and this will be in the numerator in our final answer. So we are going to convert kilometers per hour to meters per second. Right. So what we're going to do is we're going to use our conversion factors, some things that hopefully you remember. The first thing we want to do is we can get rid of the kilometers because we know that 1,000 meters are in 1 kilometer. And so here's what you do. Because kilometers is originally in the numerator, it must be in the denominator for you to cancel out these units. And we know that there are 1,000 meters in 1 kilometer. So we got rid of the kilometer units. We're not done because we still need to get our hours gone. So we need to make sure that there's hours in the numerator so we can cancel the hours that are already in the denominator. So next we multiply. The first thing I would do is just put the hours here and then cancel those hours. So you can cancel top and bottom like that. And then just look at your conversion factors. So in 1 hour, there are 60 minutes. Now, are we done? We have minutes in the denominator, but we need seconds in the denominator. So the next thing we need to do is figure out how many seconds are in 1 minute. So our goal is to put minutes in the numerator so it can cancel the minutes in the denominator. And we know 1 minute is equal to 60 seconds. So if you look, everything I've crossed out in green is gone and anything I haven't stays. And what we do is we multiply across. So we multiply 90 times 1,000. And remember, our units are going to be in meters over 1 times 60 times 60. So 60 times 60, and we have seconds here. So 90 times 1,000 would be 90,000 divided by 3,600. And that simplifies to divide 90,000 by 3,600 meters per second. And your answer will be 25 meters per second. Or you can say it like this. Either one works. And that's an example of a unit analysis problem. Here's more unit analysis problems. Perform the indicated conversions. So we're converting. That's all we're doing. Same length or weight or whatever, but just in different units. So 23 feet to yards. Well, then you have to have the knowledge that in 1 yard, there's 3 feet. So we know that 1 yard is equal to 3 feet. So 23 feet, I always start with what's given, and I put that in the numerator. And you could put it over 1 if you want, because you know there's going to be a fraction. And you want to convert to yards. So yards must be in the numerator because you have to cancel the feet. So I'll use green again. And now we're going to put 1 yard is equal to 3 feet. And so that's 23 yards divided by 3, and that is equal to 10 2/3 yard. I would not write it as 10.666 repeating because this is our nice exact answer. So I would leave that as a mixed number so it makes sense. So just divide 23 by 3, that gives you 10, and you have a remainder of 2, so 2 over 3. Okay, for the next one, this one will take a while, and we will cross out C, so we won't even do it. It's pretty complicated, and you're not going to have to do anything that drastic. But we're going to go from we're going to go days to seconds. So when we're doing days to seconds, you know you're going to have to throw in hours and minutes to make it simpler. You don't just jump from days to seconds. So the first thing we want to do is write 6 days. Write pretty small here so you can fit it in. Then we want to cancel the days in the numerator, so we must have days in the denominator. And now I would just use hours first. So there are, in one day, there are 24 hours. So we got rid of the days. Now we have to get rid of the hours. In 24 hours, or I'm sorry, 1 hour is 60 minutes. And now we did the task of getting rid of hours. Last thing we need to do is get rid of the minutes because our final answer has to be in seconds. So the minutes have to be in the denominator in order to cancel the minutes that are in the numerator. And there are 60 seconds in 1 minute. And so we are left, everything we've canceled in green, and so we see what's left. So we are going to multiply straight across. And if this helps you again, and I didn't do it for this one, just put 1 here. So we are going to multiply 6 times 60. Oops, I forgot the 24. So 6 times 24 times 60 times 60. And your units are seconds, divided by, notice the denominator is just 1 times 1 times 1 times 1. It's just 1. You don't even need to put that. Put those numbers in a calculator, multiply them, and you get 518,400 seconds. And that's your answer. Okay, for the second part of our notes, we are going to talk about simplifying expressions. Before we do that, we are going to identify the power, exponent, and base in the expression 5 to the third. So let's write 5 to the third here. 3 is known as your exponent. The 5 is the base. Notice how big it is, so big for base. And then the whole thing is called a power. And you can say this as 5 to the third power or just 5 to the third. And this is what it would look like. It's 5 times 5 times 5, not 5 times 3. So it's repeated multiplication. Things that we forget, we tend to not remember vocabulary very well. So it's really good to go over stuff like this. 90% of students miss part A, and they are going to say the answer is 169 because they just say, oh, well, that's 13 times 13. But it's not true. This is said, this is how you say it. Opposite of 13 squared. And so if you were just to do 13 squared, that's 13 times 13, which is 169. But then you want the opposite of it. So here's what we actually do. You multiply 13 times 13, but then you have a negative in front. So the answer is going to be negative 169. But most people miss it because they just assume that's 13 times 13. Now on part B, notice the negative 13 is in parentheses, so it's being multiplied twice, just like the 5 times 5 times 5, but the 2 tells you that it's multiplied twice. So it's negative 13 times negative 13. This would be positive 169. We'll go to example number 6, and now we're going to evaluate expressions. So we are going to substitute x equals negative 4 wherever you see an x. So in this expression, and you don't want to be lazy, so make a mental note, always, the A students will always do this. So always substitute using parentheses. If you don't do that, that will cost you. So replace your x with a negative 4. Notice I did it in parentheses. Then I'm going to square it. Plus 5 times negative 4 minus 12. So this means 3. Now, again, a lot of students miss this. They're going to multiply 3 times -4 first, but you can't do that. You have to do the exponents first. So don't even do anything with the 3 yet. Multiply, write out -4 twice because it's -4 to the second power, plus 5 times -4, minus 12. Notice how I'm doing my work nice and neat, vertically going down the page. So this is 3 times a positive 16 plus a -20, or you could just call it minus 20, minus 12. 3 times 16 is 48, minus 20, minus 12. I do this first, so it's 28 minus 12, which is 16. Nice and neat work, and that's how you should do it. Okay, more vocab. Identify the variable terms, the constant terms, and coefficients in the expression. So using that same example that we just evaluated, this particular expression has a total of 3 terms. But before we do that, remember variable means letter or symbol, but in algebra, letter. Constant terms mean no letter. And coefficients are your numbers in front of a variable. I use those words all the time. I use the word constant and coefficient all the time. So constant is no letters, so just a regular number without any variable. And coefficient is just the number in front of the variable. So in this case, if we had to identify the variable terms are 3x squared and 5x because they have a variable in the term. There's 3 total terms. Terms are separated by a plus or a minus sign. The constant term is just the number without the variable, and that would be -7, sorry. Notice the negative sign that is to the left of the number goes with that number. And then lastly, the coefficients are any numbers that are in front of the variable terms. So 3 is a coefficient in front of 3x squared, and 5 is a coefficient in front of 5x. And there you go, vocab. Okay, we'll finish off by doing a couple more examples. In example 8, we are going to simplify the expression now that we know what certain things are. So to simplify the expression, you can use highlighters, or you can put shapes around like terms. I'm going to use the highlighter feature. So if you have a highlighter, at least I think I'm going to use a highlighter feature. There you go. So if you have a highlighter, that works really well. So I'm going to highlight like terms. So like terms have the same variable raised to the same power. So 8x to the third is alike with -1x to the third. And just to show you, I'm going to put a 1 here because that helps students a lot of times, just to put that number in front, because the variable is not negative, it's a number in front. I don't see anything alike with 2x squared, nor do I see anything alike with, 5x, nor anything with the -11. So I'm ready to combine like terms. So 8x to the third minus 1x to the third is 7x to the third. Then I'm just going to list the other terms in decreasing exponents. I don't have to, but I'm going to because it looks nice. And that's simplified. Doing the next one, we have to go one step further first. We need to distribute. So distribute first. So multiply the 6 times each number in parentheses. So 6, a lot of students use arrows. I don't, but it helps. So 6x minus 6 minus, so this is -2 times a positive 5x is -10x. And a -2 times a positive 8 is -16. Notice I don't have any parentheses. The whole point of distributing is to get rid of parentheses. And now you can use your highlighter or draw shapes. And the stuff that I see that's alike is the 6x and the negative 10x. Notice I highlighted the negative as well. And then the constant terms are alike. And so now I'm ready to simplify them. So we have 6x minus 10x is negative 4x. And negative 6 plus a negative 16 is negative 22. And our last topic of the day is order of operations. So order of operations, and you guys all know this. You know it, but can you use it? So P stands for parentheses, but it doesn't have to be just parentheses. It could be brackets, other grouping symbols. E is for exponents. M is for multiplication. D is for division. A is for addition. S is for subtraction. This is a good review, especially when you haven't had math for a quarter. So multiplication and division have equal weight, and what you do is you do what occurs on the left first. So you do left to right. If division is on the left first, and you do division first, and then you multiply. You don't do M first and then D. It just depends. Same with addition and subtraction. They have equal weight, and you do them left to right. So knowing that knowledge, let's do examples A and B, or let's do example 9, A and B. So 9A has brackets and it has parentheses. So you're going to work within the brackets. So the first thing you want to do is do the 8 minus 1. Now, do you just put a 7 up here? No, because it's really sloppy. So I don't recommend that. I recommend doing your work vertically. So 5 plus 3 times 2 plus 5. Don't add 2 plus 5 first. Do the 8 minus 1, like that. And now you're going to do the 5 times 7. You just work inside and then move out. So 5 plus 3 times 2 plus 5 times 7 is 35. So you do this next. I guess I'll put right here, do this first. And then you do the 2 plus 35. Still don't add 5 plus 3 together. 2 plus 35 is 37. At this point, if you don't like brackets, you can do parentheses like that. And that's totally fine. Still don't add 5 plus 3. You have to do 3 times 7, 37 first. You know, I put this too far away. And then this kind of doesn't look like we should do the... So put it closer together. So you're going to do this next. 3 times 37 is 101. And so we have 5 plus 101, which would be, oops, actually I multiplied that wrong. That should be 111. There we go. And then 5 plus 111 is 116. Look how I did my work nice and vertically. Last problem. So with fractions, you can do numerator first, denominator second. It doesn't matter, but stick to one or the other. So I'm going to do my denominator first because it looks pretty easy. So 2 times 7 is 14. I'm going to do the numerator next. So in the numerator, notice you're subtracting, adding. Subtraction comes first, so you're going to do it first because it's equal weight. So 33 minus 2 is 31 plus 1. And then you have 32 divided by 14. I'm going to reduce my fraction, which everybody should always be doing. So you can divide top and bottom by 2. And that's 16 over 7. And that's your answer. And those are your notes for today. Have a great day, Algebra 2 students.